In this lesson, we will begin solving exponential equations, starting with looking at the one-to-one properties of exponential and logarithmic functions. If b to the u equals b to the w, then it has to be true that u equals w, and log to the base b of u is equal to log to the base b of w if and only if u equals w. These properties will be very useful in solving both exponential and logarithmic equations. Steps for solving an exponential equation. First of all, isolate the exponential function. Then, step 2, part A, if convenient, express both sides with a common base and equate the exponents. We'll save part B for next time. Let's solve the equation analytically. 4 raised to the power x minus 2 equals 64. The exponential function of 4 raised to the power x minus 2 is already isolated. So let's try to use the one-to-one properties of exponential functions by getting the same base on each side. I have 4 raised to the power x minus 2 on the left side of the equation. I'd like to write 64 as 4 raised to some power, and in fact 64 is equal to 4 cubed. Now that I have the same base on each side of the equation, the exponents have to be equivalent as well. So x minus 2 equals 3, and that means that x equals 5 is a solution to my equation. Next, we'll look at 9 raised to the power of 4x equals 1/3. So here we'll need to look for a base, and I think 3 will probably work. 9 is equal to 3 squared, and 1/3 is equal to 3 raised to the power of -1. So 3 squared raised to the 4x is the same as 3 raised to the power 2 times 4x. And so I'll have 3 raised to the power 8x equals 3 raised to the power of -1. So 8x is going to have to be equal to -1. If the bases are the same, the exponents have to be the same. And so x will equal -1/8 here. Try on your own. Solve the equation 1/2 raised to the power x plus 1 equals 16 analytically.